Hi there, question 6. Had me in all sorts of bother. Sorry as I paused there, I thought I heard a thunderstorm starting. It's not happening at all. Must just be windy outside. So the highway code recommends that drivers on motorways allow at least a 2-second gap between their vehicle and the vehicle in front. Work out the recommended distance in meters between two vehicles which are both moving at the maximum legal speed of 112 kilometers per hour. So we're going to be doing here, because it's speed, distance, time. We're working out the distance, so we need to do speed multiplied by time. So the time, 2 seconds. So 2 seconds times by the speed. Now the speed is 112 kilometers per hour. If we multiply that by 1,000, that turns it to meters, and then divide it by 3,600, we'll turn it into seconds. Now, run that through your calculator. I actually got 2, and then it's times by 31.1 recurring, which gives us 62.2 recurring, and I've given that as 62.2 rounded to one decimal place. So 62.2 meters. Okay, 6b. Research suggests that having variable speed limits on motorways can maximise the flow of traffic. Traffic on motorways can be modelled by using density, which is k vehicles per kilometre, flow, so that's q vehicles per hour, and speed of traffic, which is v kilometres per hour. So our first graph, we've got v, which is the speed. I'm going to write that there to help me, and then the bottom there is density. Okay, scroll it down. Explain what is happening when the density is 175 vehicles per kilometre. Well, that's this bit here on the graph, which means it's in line with with 0 on the x-axis, or the k-axis, should we say. And then because we've labelled that, we can see that that represents the speed. So therefore, speed equals 0, and therefore, cars are stationary. Cars are stationary. Okay, the traffic or traffic speed and density flow follow the model V equals A, K plus B. So like Y equals MX plus C, so to speak. A and B are constants. This is where I had a major blip because I didn't quite read my coordinates correctly. So I can work out the gradient of this by using the coordinates. So I've got one coordinate here and one coordinate where I've circled already. So that first coordinate is 175 to 0, and the second coordinate is 15 to 122. Sorry, 112. I get it right, Lloydie. So y2 minus y1, 0 take away 112 over x2 minus x1. I haven't done them the right around. I should have wrote this formula out first to show everyone. So it's like that. All that subscript mean is the y2 means y from the second coordinate. The y1 means the y from the first coordinate. So it's 1, 1, 2, take away 0, and 15, take away 175. When you plug that into your calculator, 112 over negative 160, 112 divided by 160, that gives us negative 0.7. Now, to work out what B is, I'm going to use one of these values. V is equal to 0 when negative 0.7 times by our value of K, which for this coordinate is 175. Just going to use this coordinate here, plus B. So B is going to equal 0.7 times by 175, which would have been negative 122.5, and then we add it onto the other side to give us that. So our equation is V equals negative 0.7k plus 122.5, and to answer the question, we just put our values into there. Interpret your value of A. So as density increases by 1 vehicle per kilometre, the speed of traffic decreases by 0.7 kilometres per hour. So that is a contextual interpretation of the equation, turning that mess of algebra into something that everyone can understand. Well, as the density increases by 1, the average speed will go down by 0.7 kilometers per hour. Happy with that. Okay, here we go. We've got a negative quadratic graph here. Flow Q and density K are connected by this formula. Q equals A K squared plus B K, where A and B are the values you worked out in question 6b. This model is represented in the graph below. Calculate the optimal flow, which is a maximum point. Now, when we work out maximum and minimum points for a quadratic, we could complete the square, but there's no need because a quadratic is a parabola. Right, that means that it's got symmetry down the middle. So we can just find the midpoint here to find out what that value is. So 175 divided by 2 gives us 87.5. And then we need to work out what that equation is going to be. So Q will equal AK squared. Now my value of A was negative 0.7 K squared plus, what was B? 122.5K. Happy with that? Yeah, good. Now, my value of K is 87.5. So, 87.5 times by 87.5 times by negative 0.7 gives me negative 5359.375. And then I'm going to add 87.5 times by 122.5. That is 10718.75. Okay, combine the two of them, 5359.375. And finally, that gives us 5359.375, which once it doesn't actually say to round it to anything. So I'm going to go to 5359. The mark scheme says 5360 3 significant figures, which basically covers every answer really that's accurate. Okay, finally, 13 marks is a big question. Work out the speed of traffic at the optimal flow. So negative 0.7 is our value, and then we multiply that by 87.5. And then add on the 122.5. So we're just substituting into our original equation that value there for the vehicles. And then what we will get there is 61.25. That's question 6. One question to go. Again, just a reminder to get people to subscribe, get watching. Leave the videos on repeat while you're out having something to eat. That would be great. Just help me get the watch hours. And I'll see you at question 7. Bye-bye.